Let's continue looking at the integral from the previous video, but this time let's see if we can figure out what the solid is in space that we're integrating over. To begin with, I'd like you to notice, looking at the inside bounds, that the solid we're looking at is bound below by z equals 0 and above by z equals the square root of y squared minus 9x squared. So the solid is bounded above by z equals the square root of y squared minus 9x squared, and below by z equals 0. Of course, z equals 0 is the xy plane. But let's think about what this surface is. If I have z equals the square root of y squared minus 9x squared, if I square both sides, I get that z squared is equal to y squared minus 9x squared. So this is the same as 9x squared plus z squared equals y squared. And we can recognize that as being an elliptic cone around the y-axis. So let's see if we can sketch that. If this is the y-axis, then this cone goes around the y-axis, and it's stretched more in the z direction than in the x direction. It's not super important to know. And it does pass through the origin. So let's maybe change colors for the axes. Let's maybe put the axis in purple. So that's the cone, and the cone is going to be the top surface for this region. The bottom surface is the xy plane. So let's imagine taking this cone and slicing it in half along the xy plane. So that's going to cut it along straight lines. Back here, and in the front, and same thing happening back on the far side. So let me remove the lower half of the cone so we can just look at the top half. There we go. So now we're starting to get a better idea of what the shape is. It's going to lie above the xy plane and underneath this cone. Now let's see how much of that solid that we get. Moving outward to x, we see that x is going to stay in between 0 and y over 3. Now, let me actually slow down just a little bit more and come back and look at this cone in just a little bit more detail. Remember the cone? The entire cone was 9x squared plus z squared equals y squared. So the intersection with the xy plane happens when z equals 0. And if z equals 0, I get 9x squared equals y squared. So y is plus or minus 3x. So y equals 3x is going to go into the first quadrant and the third. So the first quadrant is where x and y are both positive. So this curve in front is y equals 3x. And this curve in the back is y equals negative 3x. I mentioned that because notice the similarity to what we have here. X stays in between x equals 0 and x equals y over 3. But x equals y over 3 is the same as y equals 3x. So looking at just the x coordinate, x is going to stay in between x equals 0, which is the y-axis, and y equals 3x, which is this line in the first quadrant. So x is restricted to here. So notice that the x coordinates do not go negative, so we're not going to get this part of the cone which is above the second quadrant. We're only going to get the part which is above the first quadrant. So let me cut this in half further. And I'm only going to take the front half. Of what's under the cone. And last of all, notice that y stays between 0 and 9. So y equals 0 is back at the origin, and y equals 9 is going to be along the positive y-axis. So that tells us that we don't care about any of this part back here. So with that analysis, I think that we have a pretty good idea of the shape we're working on. It's going to be about 1/4 of a solid half cone, and it's going to be the portion which lies in the first octant. If I wanted to look just a little bit more at what's happening in the xy plane, let me turn it this way, so that y is going this way and x is going this way. That looks a little bit odd. But I just want to emphasize that this is the line y equals 3x, this is y equals 0 and y equals 9, and x is going from the y-axis over to the line y equals 3x. So if you pick this region up and you placed it in here horizontally, this triangle would be identical to that triangle right there. Now let's say that we wanted to change the order of integration. Let's say that instead we wanted to rewrite this integral into order dz, dy, dx. Let me start off by just sketching the region again, kind of blanking it out. Notice that the function z, the variable z is on the inside. So let's imagine taking a line and running it up through the solid parallel to the z-axis. So I'm going to come in from below. When I get to the xy plane, I'm going to enter the solid. I'm going to continue in the solid until I get to that cone, and then I'm going to exit. So this portion of that vertical line is going to fall inside the solid. Now the bottom point, the xy plane where it enters, I can indicate as z equals 0. So my bottom bound is going to be z equals 0. And my top bound is going to be given by the equation of the cone. and we were already given that. Here it is, but we can solve for z again to get that z is the square root of y squared minus 9x squared. So z equals the square root of y squared minus 9x squared. Now let's imagine taking this solid and projecting it down into the xy plane. Well, if we do that, we get the same region that we had before. So if I project into the xy plane, I get this purple triangle here. Now what's going to be a little bit different is now I want to do y next. So instead of having my stripes going this way, let's imagine that I'm going through this way, in the direction of increasing y. Notice that I'm going to enter on the line y equals 3x, be on the interior for a while, and exit on y equals 9. So that means I'm entering on y equals 3x and exiting on y equals 9. Notice that the smallest value of x in the region is 0, and the biggest value of x in the region is this point right here. But if the y-coordinate is 9 at that point, then that means that the x-coordinate has got to be 3. So I'd be going from x equals 0 to x equals 3. Now let's just check for reasonableness. Remember that the inner bounds can depend on the variables which are farther out, and z does indeed depend on both y and x. Y bounds can only depend on the ones farther out, so the y bound can depend on x, and it does. Notice that the lower y bound is 3x, and the bounds on x have got to be constants, which they are. And if you were to carry out this integral, then you would get exactly the same answer as we did in the first video, which was 729 over 4. In the next video, let's continue to work with this, setting up the order of integration in a couple of other orders.